Hello, everyone. Welcome to the Crownsmen Show. I'm your host, Jared Downey. Today on the show, we have Herzig Engineering, and we have their training programs manager, Caitlyn Wininger. Caitlyn, welcome to the show. Very good to have you on.
Thank you. I appreciate being here.
We just did a bunch of episodes on mining now in Australia, and there was a couple companies that had great backgrounds. I think we need to actually have a contest at the end of the year because I think your background is now in the running. That's a great setup you have there.
Yeah, we had a lot of fun getting this room set up for sure.
Your company does a lot of good videos too. I saw one about getting people home safely, and you had different people from your team saying what that meant to them, talking about family. And one answer I thought was great was the one gentleman said about getting home means about reconnecting. Where does all that? You must have a team that puts together some of these concepts. I encourage anybody to check it out. It's great stuff that you have on.
Yeah, I think what we're really trying to do is just bring home the idea that electrical safety and the services we provide are not just a compliance issue. And we
Yeah.
can definitely get more into that piece of it later, but it's a people issue. That's our main goal, is to provide the information that's needed to get people home safely. It's a people issue, not a documents or compliance thing.
Do you find when you're going out? We're gonna, of course, we've got so much to cover today. But just kicking off with that part is, do you get quite a good response from putting together videos like that? I mean, I do so many of these interviews, and you'll see so many different ways of promoting. But there's something sort of special when a company goes, okay, we're going to not talk about us here for this video. We're going to talk about, the people that we're actually trying to take care of. How has the response been to those types of videos?
Oh, it's way more impactful. Understanding why we care so much about what we do goes a much longer way than just talking about the ins and outs for most people, especially whenever you're talking about a video that you can post out online and just people watch casually versus a training session or a consult.
Yeah.
That's a little different goal. So being able to bring in that human factor and make it real, make people think about it. Hey, that looks like somebody I know, or that's a situation I
Yeah.
could think of. Definitely makes it more impactful.
Yeah, and it says something about the company because you have to I mean, of course, it is a marketing. Everybody understands that every company is a for-profit businesses, but it also just shows that the company, there are people within the company they're sitting down and thinking through it from not just through their lens, but through their clients and through the people that they're servicing. It says something about the company. It said something about you within about 2 minutes of going on your YouTube channel. I went, oh, this is different. They actually have different types of footage. It's really nice to see. Anyway, I swinging it back to let's start with just who is Herzig Engineering? What do people need to know about you? And we got lots to cover today. So let's just kick off with that.
Okay. Yeah. So Herzig Engineering was founded in 2000. So we've been around for about 23 years now. And it was built with this idea that there's a need for electrical safety services. In the safety world, there's a lot to take care of, and electrical safety is one of the more complex niche areas.
Mm.
And so Bob Herzig, the founder and CEO, he came up with this idea that, hey, we could be those specialists, take that off of the safety professionals and the facility managers' plate, work with them and take care of that side of things for them. So arc flash analysis was really the starting place. So in the late 80s, early 90s, it was the first time people even started hearing the term arc flash. And Bob Herzig, being an engineer, knew that, hey, this is going to really take off and people are going to need help figuring out the arc flash hazards. It requires an engineering study to do so. So that's kind of how he started the business, was with arc flash studies. And then it just grew from there to training and other kinds of studies and analysis and audits and all sorts of things, just as we started working with companies and seeing what they need and what they're requesting help with.
Is this on-site work, the primary services you provide, or is it all different levels of analysis, like remote work and those types of things?
Yeah, so there's a few different ways that we approach a project depending on what it is. For our bread and butter service, the arc flash analysis, we usually start by sending a master electrician on site to collect the data. And it's important that we use someone who's qualified, like our master electricians, because they have to be able to access and open up all the electrical equipment to gather the data. And so we're sending people that are qualified to do so and won't also create a hazardous situation. So they collect all the system information and then bring it into the office, and our engineers will work with it to put it in a program and analyze the results of the calculations and getting into the kind of the nitty-gritty of what engineers like to do, and provide recommendations on how to improve the system's safety. And then the field techs will go back out, the master electricians will go back out to the site with the labels. That's kind of the key factor for an arc flash study, is getting those labels on the equipment so
I
that
saw a
workers
video about that.
know
Yeah,
what to wear and how far out the hazard is.
Yeah, you actually have another. And by the way, to the audience, we'll put links to all this in the description. You have another video about that, right? How the different types of labeling and actually walking everybody through it.
Yeah, those labels are really the key thing for workers to know. So not only do they go out and apply the labels, but then we always offer a complimentary training session, because if people don't know how to read those labels and utilize the information properly, it's not going to help them. And our goal is to help the people. So yes, you have to have the labels on the equipment, but we want to make it useful.
Where did you start with the company? Where was your?
So I was going to school for electrical and computer engineering, and there was a classmate of mine who had been working with Herzig Engineering, and I was just curious, so I looked it up and asked if there were any internships. I finished out the one that I was currently at and started with Herzig doing just the data entry, kind of the entry-level position of putting the data into our program so that the engineers can work with it. And that gave me a really good fundamental understanding of what information we use. And then once I graduated, I started doing the engineering analysis part of it. So reviewing the data, making recommendations, things like that. And then they wanted me to get some field work, because an engineer knows a lot about stuff in theory, but applying it practically takes field experience. So they sent me out with some of our electricians, and I got to see the data collection process and all the intricate systems that could possibly be out there and why you have to know so much to do that job. And then as part of that, of course, with the training aspect, because we always want to give the workers that training, I had to sit in and start learning how to do that. And after a while, I ended up giving a presentation, and Bob Herzig was sitting in listening to it. And he said, we got something going here. You need to get more involved with that. So he had me work a lot with our training content and keeping it up to date. And I start training other people how to give the training. And so now I'm actually the training programs manager. So I found my little nook in the company with that.
Wow, congratulations. And how long have you been with the company?
It's just over 5 years now.
Wow. Well, congratulations. Do you remember the first time you talked about getting on-site experience? Do you remember your first project still that you actually went on site for?
Yeah, it was actually a local project, and it was for a label application. So I didn't have to open anything up. Thankfully, I wasn't qualified to do that yet. But it was to apply the labels to equipment and then provide the training, or co-provide it, because I had an electrician with me. And that was quite fun, being able to walk around and see the results of what I'd been doing on the computer in real life.
Right.
It was pretty cool to tie it all together that way.
Well, I actually wanted to clarify, and anybody in the electrical field, they probably know, but I don't. You said you were taking what were you taking for? You were taking electrical engineering and computer?
Yeah, so the college that I went to, the university, it's electrical and computer engineering combined as a degree. So it was both sides. And so it was a lot of programming that I didn't necessarily use after graduation, but it gave a more holistic approach to what you could do with electrical engineering.
But they were directly connected to each other, the two programs.
Yes.
Right.
Let's talk about our Heavy Industry World Tour, brought to you by Savannah Equipment, supplying mining equipment worldwide. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsmen.com to be part of Crownsmen's Heavy Industry World Tour. With Fender Dunlop, you know you are getting the best conveyor belting in the market. That's because they ensure the integrity of their conveyor belting by monitoring each step of the manufacturing process in their North American facilities. Focused attention is given to each belting order to guarantee that they produce a belt that will assist the customer in reducing operation costs, maximizing uptime, and improving revenue. Visit FenderDunlopAmericas.com to learn more. L&H Industrial can custom engineer and build from the ground up any heavy equipment assembly or machine that you need for your operation. Their worldwide 24/7 field services network is on the job whenever you need heavy equipment troubleshooting, repairs, rebuilds, relocations, or replacements. And thanks to their specialized design and engineering and state-of-the-art manufacturing and repair services, they are a go-to international supplier for improved components and custom assemblies for heavy industrial machinery. Visit lnh.net to learn more. Studs and helmets use cutting-edge head protection components used previously only in extreme sports helmets, now utilized in both of Studson's Type 2 models. The SHK1 and SHK1 full brim models are the most innovative helmets on any job site. Offering a revolutionary combination of Koroyd and Twice-Me technologies, this Studson full brim helmet is the first of its kind in the Type 2 category, providing you with the protection and comfort you need to get the job done. Saving lives one helmet at a time. Studson, where safety meets innovation. You can visit them at studson.com to learn more. OptiSize is a leading-edge geophysical acquisition design and software company. OptiSize provides innovative seismic survey designs utilizing the latest field technology and optimizing for advanced processing and quantitative interpretation techniques. OptiSize's mission is to bring sustainable exploration solutions to energy development with their custom land footprint reduction technology, EcoSize. EcoSize enables operators to focus on reducing their environmental and greenhouse gas footprint while imaging all their subsurface targets and reducing costs. You can visit them at optisize.com to learn more.
And so what was the type of programming what was the computer side of it?
Well, so the computer side of it was more understanding how like computer systems work. So that logic can still be applied to electrical engineering whenever you talk about the control system side.
Right.
Or if you wanted to go more focused on the computer engineering side, the electrical systems explain how the controls are powered and operated and things like that. They do tie in together pretty closely.
The so let's go back over to Herzig on so let's talk more about the arc flash. Can you first explain to anybody who doesn't know what arc flash is? Just walk us through that first.
Yeah, so first off, arc flash, what is that? It was something that term was coined back in 1986, I believe, whenever Dr. Ralph H. Lee, a principal engineer at DuPont, published a paper called The Other Electrical Hazard, Arc Blast Burns. And what he had done was started the serious study of arc flash events because before nobody even knew what it was. So what he did was came up with some calculations that we then modified and used later on throughout the years to predict how severe an arc flash could be. Right. So the arc flash is essentially an electrical explosion. That's kind of the simple way of putting it. Basically, if something crosses phases, phase to phase or phase to ground, it could be a tool, it could be a fuse, it could be wildlife. I mean, critters get into our equipment all the time. If anything causes a short circuit or a fault that starts arcing, it can ionize the air around it, creating a massive and traumatic explosion, melting and flinging pieces of equipment around. I've seen videos and heard stories of it picking up and throwing a full-grown man across the room. That's the arc blast side of it. It can deafen and blind and certainly burn. The biggest problem is that it burns people really badly, sets their clothing on fire, that kind of thing. And so end up with a lot of burn victim stories whenever you talk about arc flash hazards.
Yeah,
it's an electrical explosion.
Yeah, I've seen some of the videos online. Like when I saw a test where they had a mannequin in there, and it was insane what it did. What happens on site? What is day one or the initial process when you get to a client's site?
Yeah, so for an arc flash study, we start out with a safety meeting, which seems kind of straightforward, but it's true. We have to know where the equipment is and what the emergency response procedures are, because our master electricians are getting into live electrical equipment.
Right.
The way that they've been trained and qualified to do this job, the site does not have to shut down any equipment for us to get the job done, which is nice. There's no interruption to operations. We just go in and do our thing and leave. But that requires some initial meeting up front. And then they go basically to the main electrical room. wherever the incoming power is feeding your facility, that's a really good place to start. And then they begin collecting the data. They look at the switchboard, switchgear, main distribution panels, whatever it is you have. They write down the information of what it is, where it's fed from, where it's feeding to, and they take off all the covers so that they can see the wire sizes and the breaker settings or relays, any fuse types and sizing, how many conductors are per phase. All that information is needed for the study, for the analysis. So they write it down, take pictures where needed, and move on to the next room, electrical room. They trace out the circuits to make sure that they know where everything is fed to and how much load there is. So like large motors, things like that, they'll write those down. Basically, they start at the beginning of their system and try to work their way through every branch and create a one-line diagram of their electrical distribution system with all the details that us engineers need to run the calculations.
And then how much information do the clients have before you show up on site? I'm just trying to think of different scenarios. Like if this is a brand new facility, a lot of that information they would have it, correct? So
Sure.
what are the scenarios where they don't even have that properly laid out?
Yeah, so new facilities, like you said, oftentimes they have their bill of materials or their, as-built drawings, and we can pull from that as a good reference. But most of the facilities we end up going to are ones that have been around for a long time, and either they don't have up-to-date drawings or nobody knows where they are, to be honest.
Multiple owners, multiple companies.
So we're starting from scratch. Oftentimes, by the time we finish a project, our electrical one-line diagram that we've created for the study is the only one that their workers have available to them. So sometimes that's the main takeaway that, their electricians are excited about. They're like, we finally have a system diagram, because, it's easy to lose track of all the renovations and changes that people do throughout the years, especially with like a manufacturing environment or a processing environment. You're adding in new lines or changing out equipment or whatever you need to do to adapt to your needs. And updating your documentation is not always top priority. So we have to just take a look at what's actually there and write it down from scratch most of the time.
Wow. Yeah, as you're saying, I realized, a lot of buildings, some of them I've been in, they'll go through multiple owners. These buildings sort of have a life of their own. They're putting in new systems and powering new equipment. And over a building, I mean, some of them are maybe 40, 50 years old. Who knows? Well, I guess eventually you'll know. But yeah, I could see how you'd end up with a whole bunch of stuff going on, and people are in their little sections, so they might not interact with those different electrical circuits and everything like that. So then you take that to a client. What happens? What's the next phase? Once everybody, I'm assuming that you then meet with the client and then go through it. What are sort of the following stages?
Yeah, so after the data is collected, and that can take, a week, couple weeks, depending on the size and how much equipment there is of on-site time for our field people. But most of the time, once they get done with the data collection, it comes into the office. And we have an engineering team that will review the data that was collected and ask questions to our field people, making sure that, anything that doesn't quite make sense or doesn't look right, we can talk through it. Sometimes these older electrical systems really are just kind of strangely set up. And so an engineer looks at it and goes, this doesn't seem right. But the field tech, the electrician, can be like, no, that's actually what was there. And sometimes, they write it down and it doesn't really make sense. And we go back and we look at it and there's something tricky about it. There were multiple feeds and we crossed which way something went, and we can catch those kinds of things. So the engineering review part of the data is very important, just so that we know what we get entered into the system program makes sense. So they look it over, they have the engineering team enter the data, typically like an engineering intern or one of our electrical data analysts who are trained and knowledgeable on how to work with this program. And then we run reports, we run the calculations, they look at the results and try to figure out how to lower those arc flash hazards. And that could be from numerous options like breaker setting replacements, fuse replacements, adding new equipment, all sorts of things. They're looking at how can we lower these hazards so that whenever people do have to get into this equipment, it's not going to be such a huge and traumatic arc flash event if something were to happen.
Caitlyn, could you add in just some specifics when they're doing the inspections and the recommendations? Like what are some specific things that they're looking for?
Yeah, sure. So whenever the engineers are working with the data in office for that study, they do want to provide some recommendations. It's helpful to know the results of what's currently there, but let's say you've got a piece of equipment that people have to get into all the time. We want to see how we can lower that hazard so that there's minimal PPE required and also, less likelihood of somebody getting to the hospital or worse, right? So what kinds of recommendations we're looking at oftentimes will just be looking at your breakers, looking at your relays, seeing what kind of setting adjustments might end up lowering the hazard. It's a matter of how fast we can get the arc to extinguish if there was a short circuit event. So the faster we can get it to operate without causing miscoordination is kind of that fine-tuning piece of the analysis. So looking at those settings, they actually do things, don't just go turning them willy-nilly. So settings on breakers, that's kind of a key piece. The other side of it is a fuse replacement. So something that a lot of people don't realize is that the class of fuse makes a big difference on how it operates in your system if there was a fault in your electrical distribution. So a 200 amp fuse set blows, someone just grabs the next available set of 200 amp fuses, they could have drastically changed the results of the analysis downstream of that point because those classes of fuses are different. So for example, an RK5 style fuse is often one that we see in place, and it might have a higher arc flash hazard rating downstream of that. And if we recommend the same amperage size of fuse, but use an RK1 style fuse, it's going to operate a little bit differently and shorten the amount of time that arc flash can occur, and oftentimes can lower the hazard ratings, so the level of PPE that's required. So that's the kind of things that they'll mostly look at. If there's a significant hazard and the client really wants us to, we will also look at adding or replacing equipment altogether. So like adding a new disconnect so that there's another level of protection in the system. But those tend to take a little bit more effort with the equipment suppliers as well. So most of the time we try to look for those quick fixes. That's what people want, an easy solution. But it's not just about looking at the arc flash hazards. You also want to make sure that your system is coordinated properly. And what I mean by that is if there's a fault, you want the device that's directly upstream to operate, not the main disconnect for the entire facility, which often happens in an arc flash situation because they don't have proper coordination. So looking at what we call TCC curves or time current characteristic curves, we can line up all those protective devices so that they protect the area of the system that they're supposed to. And at the same time, still allow for motors to start or the inrush current needed for a transformer, basically just your normal operations. We're not going to set anything to the point that as soon as you start to turn on your machine, it starts tripping. That's a nuisance trip. We don't want that. So it's kind of a balance. It's a dance between lowering the arc flash hazard versus trying to make sure that your system is properly coordinated.
Why do people call you initially? What is usually the trigger point that gets people to get you in?
That would be a handful of things. So one of the more common ones is that there's either an insurance issue. Insurance companies are starting to push it more because they're recognizing that not covering electrical safety, even though electrical accidents don't happen as often, they are some of the most costly incidents to deal with. Not only do you have the extensive recovery time for whoever was involved, or worse, they don't actually survive, but you also have all that equipment that's been damaged and needing to be replaced. Sometimes the facility itself is damaged and needs renovations to get back up to code. And I mean, it's a huge, huge deal. So insurance companies are starting to push it more and more. And so sometimes they get close to re-upping their policy and, hey, you don't have an up-to-date study, you better get it done, or we're going to charge you way more, or we're going to drop you. So that's one major factor pushing recently. But previously, it was more just, if somebody had heard of an incident happening, or if it was safety professional who previous job, they'd always made sure that that was taken care of. And now they're trying to get this new company up to speed with it. There could be a number of factors, but worst case is whenever we get called, after an arc flash has already happened,
Right.
and that they're trying to get a study done so that, future times there's not any issues. But the old slogan that we had, Bob Herzig used all the time, don't let safety happen by accident. Don't call us after someone's
Yeah.
already gotten hurt. We want to help avoid that.
Yeah, and that's what I was alluding to, and I wondered if I'm sure you don't have the exact number, but how many of your calls you're getting sort of after an incident, as opposed to, do you find now though that you sort of maybe alluded to it a bit, is that are people, because of insurance and that, people are getting a little more proactive of getting rather than reactive?
Yeah, I think that there's also just a lot more awareness that's helping with that proactive attitude. Just understanding that it's not as rare as people think. It doesn't happen as often as like a slip, trip, and fall or a crush injury or a car
Right.
accident, but it's not as rare as like a shark attack either,
Right.
or a plane crash. People are terrified of sharks and plane crashes, but arc flash happens way more often than that. And just understanding that, it's a real and it's a prevalent issue for anybody who has to open up electrical equipment. And every time they open it, there's that lurking threat, there's that hazard. People are understanding that more and more, and they don't want to leave it to chance nearly as much as they used to.
I want to actually go through some of these. You shared some of the labels, and I actually want to walk through a couple of them because you've got something quite nice. You've got a picture of a label. Of course, we'll bring it up for the audience, but then you have different spots that it is going to be. And I am definitely one of those people. I try to pay attention, but I'm sure I've walked through plenty of these types of environments and just glanced at these little labels and really, I probably read 2 of them in my life. So I'm going to do it.
Fair.
I'm going to do it properly today.
Our culture is very label happy. We put stickers
a lot
and
of
labels
labels
all over the place, but the key are the people who needing to read them actually reading them.
Right. Well, that's the thing. Let's go through it. So we've got this one up here, and I see it's got about 8 different colors on it, and so just walk us through what are we looking at here?
Yeah, so that is just an example of what our warning labels would look like once they are printed for you, and it's explaining what the information entails. So the results of the analysis is called the incident energy. So calories per centimeter squared, meaning how hot or how severe over a surface area will that arc flash burn potential be. And the working distance, so it's at an 18-inch working distance. If you're standing in front of a piece of equipment about 18 inches, this is how much of a hazard that you're facing, because it's based on heat dissipation from that arc event. And then we've got the arc flash boundary, which is how far out that arc flash can still hurt somebody. So think of that as kind of the blast radius. You want to keep people out of the arc flash boundary in any direction, not just directly in front of the equipment. What we do is we label out the specific PPE requirements. So we list out, it's like, okay, for this high of an arc flash hazard, these are the items of clothing or protective gear that you need to wear in order to protect yourself. If this arc flash were to occur and you're wearing this equipment, you will probably be pretty scared, but at least be able to walk away from it. We also put a site-specific PPE level, and this is going to mirror what PPE suppliers most of the time mark their gear as. So, for example, a shirt and pant that says a big old 2 on the sleeve and the pocket, well, that's considered okay for up to 8 calories per centimeter squared of incident energy. So if you know what your PPE says, it makes it a little bit easier to pick the right items. Another important part of this is not just the arc flash hazard, though. You also need to be aware of the shock hazard. That is something that hurts and kills people even more often. And so knowing what the highest nominal voltage is that you're facing and what the boundaries are for that, as well as the glove class you need to wear, the rubber gloves that go on your hand to keep you isolated from that energized circuit. And then the boundaries keep people out, for example, and this one shows 42-inch limited approach boundary, which is pretty much set for low voltage equipment. The arc flash boundary is 57 inches. So we would want to set up our barriers or our barricades out to 57 or more inches away from the equipment. Sometimes that arc flash boundary is lower though. And so 42 inches is the bare minimum. You don't ever want to set up your boundaries less than that because you don't want people exposed to the shock hazard either. The available short circuit current is another important piece of information that oftentimes you can look at your enclosures or your breakers and make sure that, if there's a fault, 9.6 kA of available short circuit current is going to pass through it. Is that equipment rated for it or not? Because even if it doesn't instigate an arc flash, if there's enough current passing through it because of a fault, but it's not rated for it, then that piece of equipment could actually blow up because of that. It's
Right.
a whole different issue, but still important piece of information. And then just wrapping up with the panel name at the bottom. And I will note it says warning at the top with an orange background. That's per the ANSI standards. If it's over a certain point of a hazard, so typically 40 calories per centimeter squared is the cutoff, then that would change to a red background with white lettering that says danger. And that's just simply because most people don't have PPE rated for higher than 40 cals per centimeter squared of an arc flash hazard.
I see. I'm
So that's kind of the gist of what all the information is on that label, and why it's so important to go through not just what is it, but why do you need to know this? How does it apply to you? And what do you need to do about that?
Yeah, I'm looking at this going, I wonder how many times I have been in an environment where I was not, probably everything here was wrong. Like it's
Okay, fair
yeah,
enough.
yeah. Unfortunately, yeah. No, I've been on sites where I wouldn't have. I've never read a label like this. I've seen the warning label. I went, well, warning. You can probably get shocked over there, but I've never.
Yeah.
I've not. I did. Of course, electricians would, but I've been working around
Well-
electrical and never. Or no.
Well, I was going to say, it's like from personal experience, I know that that's not necessarily true. Electricians going through trade school to get like their journeyman or master electrician,
Right? Yeah.
not all the time do they ever talk about electrical safety. Like
Yeah.
they'll go through the mandatory OSHA trainings, but understanding what arc flash is and how it can hurt you and how to use information from an arc flash study, that doesn't really happen. My brother is a journeyman electrician, and the only time he heard about arc flash and how to protect himself from that was because of me.
Wow.
I was like, you need to know this stuff. So no, it's not a given that electricians would know this information. That's why we always, every time we do this study, we provide training, because we don't want to assume that they know what this
Right.
is.
Yeah. Oh, yeah. It's people talking exactly how I'm talking. It's like, well, I'm sure they know. You're running a
Yep.
site and you're not an electrician, but you operate that site and you just assume an electrician knows, and they may not. And something that came to my mind too, across the U.S., Canada, we have do a lot of episodes in Australia. The worker shortage right now. People are trying.
Yes.
They're trying to get. So I can just imagine. I just did an episode out of Australia, bringing in people from other countries to trying to onboard them and train them. I can just imagine how easy it is to make serious errors in the safety training because you're focused on the technical training. And if this is not a focal point, yeah, I could see how it get missed very, very easy.
Yeah, whenever we're talking about worker shortage, that's another good point. Oftentimes, electrical work is not being done by electricians anymore. There's maintenance crew that suddenly they have some electrical tasks that they have to do now without that proper training and qualification. So it's adding to a lot of those injuries and fatalities that we see in our unfortunate statistics.
Yeah. Oh, me, 21. I'm sure I've done lots of electrical work in my time, and I am no electrician. And that'll just get
a lot
more
of
and
people
more.
get into places they probably shouldn't.
Yeah, it's where are you doing business? Where's your main focus?
So we are out of the Kansas City, Missouri area, but we go nationwide. And we've also traveled outside of the country for certain projects. Canada, Mexico, Germany, China, and a few others that aren't coming to mind at the moment. But mostly we focus on the United States. And, being in Kansas City, it creates a really good hub for our field people who travel every week to fly in and out
Right.
across the country wherever they need to go that week. So it really is a nationwide and industry-wide, whether it be general industry, construction, manufacturing,
Yeah.
food processing, all sorts of things. If you've got electricity, you need electrical safety.
Is Kansas City one of those? Sorry, random question that came to my mind. Is Kansas
Yeah.
City one of those cities that a lot of people are migrating to? I feel like I've heard that. Is that true? A lot of people.
I
Is it a
have
growing
seen
city?
a lot of apartment buildings being put
Yeah,
up and a lot more people in the area. I think part of the draw is well, sports. We've got the Kansas City Chiefs,
yeah,
won the Super Bowl a couple times, no big deal. So a lot of people are getting a good spotlight on Kansas City right now.
yeah. You hear there's quite a few cities in the U.S. You hear about just people
Yeah.
like yeah, well, obviously like Houston and Texas. A lot of people are just flocking to these cities. It's quite interesting to see.
Yeah.
Did what was it? Oh, Skate. Can you just touch on again the industries? I mean, electrical, of course, it's in everything. Are there some
Right.
primary? Are there sort of some, or are there any examples that stand out to you that you can go, this is an example of a project where, the impact was just so clear. It's a great project, a well-known company. Is there anything that sort of stands out to you?
Yeah, so like I said, it's pretty much any industry that you can think of. If they need power for anything, they're gonna have some hazards associated with that. An example could be like the food processing.
Mm-hmm.
So Tyson Foods is a partner of ours that we've worked with for pretty much all of their facilities, or we're trying to help out with all the rest of their facilities. We've been working with them for years just to keep up to date with their arc flash analysis and provide training and keeping their facilities compliant. It's one of those situations where you don't think about, a ranch or a butcher or some other kind of food processing needing so much in the way of electrical safety, but I mean, they still have that power that they have to work with and keep running so that their processes continue. So that would be a good example. We've done all sorts of facilities for that. It's a wide range.
And so on something like that, but the key is these, I mean, these production facilities, they're not being shut down while you're in there doing your work. So are you sort of like moving, like, are you in basically the electrical rooms, or are you in everywhere having to go throughout these facilities?
Wherever the equipment is. So
Yeah,
panels, disconnects, motor control centers, switchboard, switchgear, some control cabinets, because they'll actually have some power distribution going through them as well. So pretty much everything. Definitely electrical rooms. We start in there. We try to get all those, but we go out to where the equipment actually is as well, just to make sure that we dot all the I's and cross all the T's, so to speak, of the electrical system. Anything that could have an arc flash hazard, we want to look at. And so yeah, that goes down to even equipment disconnects.
right. So yeah, I imagine like a Tyson Foods. I mean, their facilities, it'd be all so different ages of buildings.
Yeah.
There's probably some like they started off as one building, they've added stuff on. I imagine you're running into all kinds of stuff, right?
Oh yeah, there's some unique facilities that they have for sure. And it's interesting to see, whenever they do acquire a new facility and we come out to help, the transformation that has to go through in order to
Yeah.
to get up to speed for what their safety standards are. And it's good to see that they take it seriously.
Yeah, and I kind of wanted to circle back to that. Again, not being an electrician, so I apologize if it's sort of
Mhm.
a fumbly question, but it would seem that like some of these, I mean, I'll use an extreme example, like you get like a Tesla facility, for instance,
Yep.
where they're repurposed. It's still a manufacturing plant, but it's so many updates. But they're using some of the existing infrastructure and then they're merging it together. You must just see some wild stuff as it all sort of gets it up to production.
Yeah, that's actually an interesting point. So, one of the gigafactories for like battery manufacturing and stuff, when you said Tesla, that's what reminded me of
Mm,
it, that we worked with part of that, and seeing how it all integrates together and
man.
all the changes that happen, it's incredible. And especially with the newer industries and how much larger facilities are getting just to handle all of this, these can be some pretty big projects that take a significant amount of time. And
Right.
typically with those kind of companies and facilities, they have electrical engineers on staff that probably could do this study. They're licensed, they have that background. It's
Right.
just they don't have the time.
Right.
This is a time consuming process to get everything done. And so we just like to take it off their plate.
Yeah, yeah. Well, same as our business. People can put up cameras, but they end up getting us to
Yep.
do it because it's just that people are busy doing the other stuff. Did
Yep.
with the electrification, have you? I wanted to get into a little bit before we wrap up about like the OSHA like standards and following those guidelines. But I just wanted to quickly ask about like electrification. That
Mhm.
must have that must open up or does it open up new opportunities for your business as companies are trying to electrify more and more processes and just their facilities, getting them up to date? That must be a huge opportunity for your company.
Yeah, we do have a lot of people that are starting to reach out to get their facilities updated, or they're just now thinking about it because there is so much, like you said, electrification in their industry. It's interesting because the studies and testing that have been done for like electric vehicles or DC arc flash events, not necessarily at the vehicle, but maybe the charging stations and the inverters and all that kind of stuff,
Hmm.
maybe solar panel stuff, wind energy. There's been a lot of research into how arc flash hazards might be prevalent there and how to handle that in our studies. So IEEE, they do an electrical safety workshop every year. And, last year I went and they were doing a lot of talks about that, understanding at what point do you need to include this in the study versus, it's more of a shock hazard. So it'll always be a shock hazard. That's going to be an issue that I think a lot of people are trying to address, but figuring out the cutoff of where to include it in your arc flash study is relatively new, and our
Mm.
engineers have a pretty good handle on it, but they're always looking for more information to keep up to date.
What let's talk about again before we wrap up. Let's talk about like um, actual regulations in that.
Sure.
Are you seeing, are there new ones coming out? Are there, actually, maybe I'll just handle it because I don't know really what question to ask, but I know
Okay.
it's becoming more and more relevant to talk about. So can we talk about some of the regulations either that are in place or coming into place?
Yeah, absolutely. So what we mostly are looking at whenever it comes to electrical safety regulations is OSHA. That's kind of the big ticket of electrical safety, looking at either general industry or construction industry. So that'd be 1910 subpart K and subpart S, depending on if you know that information. But they don't have all the details about how to handle the electrical safety requirements. They say protect your workers, but how? So they look to NFPA to help provide the codes and standards that people can follow in order to be in compliance with the OSHA regulations, if
Okay.
that makes sense. So we have three main books that we look at whenever we're talking about electrical safety codes and standards. So we've got the NFPA 70,
Oh, you
the
actually
National
have the
Electrical
books.
Code, oftentimes referred to as the electrician's Bible. This is the main guideline for how to install equipment and make sure that it's done right and safely. One that more people are getting to know better is the NFPA 70E. So this is the one that I live in most every day, is the standard for electrical safety in the workplace. The piece that I like to highlight any chance I get now is, as of this year, we have the NFPA 70B. Before it was a recommended practice, but it is now a standard, meaning that it is a requirement. So it was the standard for electrical equipment maintenance, meaning that if you don't have a good, solid maintenance program, then the safe work practices from the 70E have to take that into account.
Mm.
Your arc flash studies, if your equipment is not maintained properly, your arc flash studies are going to have much more severe results because it's based on how fast we can extinguish that arc, how fast a breaker can operate or a fuse can blow. And if your equipment's not maintained properly and it takes even a fraction of a second longer to clear that
Mm.
fault, your arc flash hazard can be way higher. So not only that, but if you're even just operating a circuit breaker and it's not been maintained properly, that could blow up on you. It's insane. So the 70B got elevated to a standard to help people
Mm.
realize it's not just installing it and then working around it safely, but
Right.
we also need to make sure it stays in a safe and reliable condition after it's been put into service.
Right.
Otherwise, you're opening up to even more issues.
Well, some of these sites, and I imagine you go to some of them too, maybe a food processing site, things like dust and that would be a little more limited. I mean, not completely, but more.
Sure.
But things like we do a lot of mining episodes. I mean, those environments, maintenance is. I mean, we've done episodes about the maintenance
Yeah.
side of the electrical. I mean, the consequences, like you've already talked about, are huge. Um, are you going into those types of sites a lot? Those for lack of a better word, just those the dirty ones, the lots of
Yeah.
dust, lots of there's oils, there's just a lot of just the environment is a rugged environment. Is that a big part of the business?
Yeah, we have a lot of people who come to us because, they go and get quotes for a study or an audit or something like that. And then we're the only ones that end up actually bidding on it because we're the ones willing and know how to work around those
Right,
kind of environments without opening ourselves or the facility up to unnecessary hazards. Because it's a tricky situation to work around like hazardous or classified areas.
right.
But it's something that we've just had to get used to because that's what people need, and we're trying to fill that market. So, mining specifically, like you said a moment ago, that can be a pretty challenging one to deal with. I
Yeah,
was at a facility just a few months ago up north that it was a mining facility. They'd had the mine just right up the road from, I could see it from the office building. It's pretty cool. Doing their electrical safety program and worker audits and things like that. And it was a little bit of a curveball, like
yeah.
talking about how to do your job safety planning. There's additional steps that other facilities don't have to think about.
Yeah, well, in mining, everything's it's bigger. It is just a very different environment than really anything else. In your
Yeah.
career, what you've been with the company for 5 years, which is it's actually not that long. I'm thinking, I mean, I had people. I have. We do interviews and people have been. I mean, just literally much longer than I've even been alive. It's been
Sure.
crazy. It's crazy. But you've also packed in a lot into 5 years. Where in that time, what was the different positions, the different things you've learned? What was the big challenge? What has there been one that stood out that was like, okay, I'm stretching myself now.
Yeah. I think that probably the hardest piece is whenever you're trying to not just apply the standards as they're written, but
Mm,
trying to customize it so that you follow the minimum requirements, but make it so specific and applicable to the type of work that's actually being done,
right.
and creating levels of qualified workers. People struggle with that quite often, and it's something that I've really focused on in the last couple of years is just how do we list out, what actually people are doing, and then
Mm,
figure out how to line up your safe work practices to be more specific and take out that guesswork as much as possible so that the workers, when they do this task, they know XYZ safety requirements apply, and when to do your risk assessments and all that kind of stuff. So that's been an interesting challenge. Is there's so many different operations and ways that things are happening,
mm.
whether it be DC high voltage hazards or low voltage but high arc flash hazards. It depends on the situation, but you have to be very careful about how you approach that,
And
making
the
sure people are qualified for their task.
Right, and the communication, what is that like? Is it a mixed bag when you're coming on site?
Mhm.
Again, I've worked on site, so some like safety things, and somebody will one person's maybe right into it, then another person sort of
Yep.
rolls their eyes. You get all these different personalities. Someone's been on the site for they've done this job for 40 years. They maybe even been
Hmm.
zapped a couple times. Like they're just you just get these personalities, or someone young that doesn't
Hmm.
even know you're talking about safety, but it's so new to them. It's not, I'm sure you've seen that, like it's not even registering. It's kind of you
Yeah.
don't know what you don't know. Um, how do you approach that? Getting all these different people, all these different backgrounds and levels of experience, levels of engagement to sort of get in a room and get on board, because I know that can be quite challenging.
Yeah, whenever you're talking about having a culture shift, especially whenever you've got a mix of new people who really don't know where they're supposed to fit in this conversation versus more senior people who have been with the company for years and years and years and they've always done it a certain way. changing that mindset and coming together to create a more safe environment for everybody can be a challenge. And it comes down to anytime I have the opportunity to have those discussions that are more open form, because oftentimes the concerns and the pushback that I hear, there's a simple solution, but people aren't voicing it because they don't want to have that conversation. They don't want to feel like they're wasting their time talking about something that they're not going to do anyway. So if I can get them to start talking and just listen to what they have to say, oftentimes I can point out that I'm like, I understand what you're saying, and here's a pretty simple solution. And even if then that doesn't work, sometimes it'll just be a coming to Jesus moment, so to speak, of you're here to do a job. You're getting paid to do that job. Your company's saying part of that job is to do it safely. End of story.
Right.
Sometimes you have to just draw the line, but most of the time, having that
I
open
like that you were
discussion
honest about
really
that. Because
resets the tone.
yeah, I'm glad you said that, because sometimes on these interviews, I know people they kind of don't want to say. Sometimes you just got to be like, and you do. Sometimes you just have yeah. But no, you've covered so much important ground, and sometimes in these interviews, you have so much experience. Sometimes I'm just hoping I've asked enough questions to bring out your experience in the interview.
Sure.
And I've sort of been adding a section to almost all the interviews just in the last few weeks, actually, because again, and people are probably sick of hearing me say it, but I'm picturing someone watching the interview and be like, "Can you just ask this? This is what this is what I need to know," and you keep not asking it. Are there any common questions before I let you go that you get that are just important questions? Is there anything that jumps out to you? Go, I want people to know that, or it's a common one I get.
Sure. So in the early 2000s, we had arc flash hazard safety starting to be pushed by OSHA. And so some people had their studies done as early as, back then. The thing is, every 5 years, you need to have them updated. So I guess the question I would have had you ask is how often do these analyses need to be performed? And it's at a minimum of every 5 years. And that's for a number of reasons. More recently, because the calculations have actually changed. So we have better, more precise versions of the analysis methods, and we want to make sure that everyone has that up-to-date calculation, but also because the utility contribution changes, so the available fault current in your system can change, and you got to make sure that that's up to date so that if there's a higher hazard, people know about it before they get in next time. And then it says at a minimum, so every 5 years at a minimum. If you change something, the study is no longer valid. So if you've reran a piece of equipment from that point down, those labels don't apply anymore.
Right.
Or if you've changed a setting on a breaker, anything from that change down doesn't apply anymore. Or you swapped out fuses with a different type of fuse. Anything that changes what is seen on a one-line diagram, for example, if you were to look at a system diagram, if something on there changes, the study needs to be updated. So it's not a one and done thing, I guess is my point. It needs to be done every 5 years at a minimum, or if you've changed something that could call into question the results of that study, get that label updated.
This interview has made me feel very fortunate that I'm here and healthy. I just know some of these places I've been, they were not updated every 5 years or maybe ever. Sure. Thank you very much for doing the interview and sharing all the information. I hope your company keeps putting out, and I've seen that you personally do a lot of the content as well. I hope you keep putting it out. It's really nice to see a company engaging in that way, and just putting that out online. Just not even your clients, just people to share and take in that information. It's just great. So I hope that keeps coming because it's good.
Oh yeah, that's definitely a main initiative of mine right now, is to just bring more awareness out there, just so that people stop taking it for granted.
Thank you very much, Caitlyn. I hope this is not the last time we are on the show, and I'm glad you touched on that every 5 year, the maintenance part of it or the updating part of it, because that was a pretty key piece of information.
Yes.
Thank you very much. We'll talk to you soon.
Thank you so much.
And thank you, everybody, for watching. We will, of course, put links to Herzig, their LinkedIn, their website. Reach out to them, their YouTube channel. I know I mentioned it a couple times, but it is a very good channel. So go check that out. And then we'll also, as long as Caitlyn's okay with it, we'll put a link to her LinkedIn if you want to connect with her directly. Thank you, everybody, for watching. Please keep sharing, subscribing, suggesting guests. It's we get locked in our little bubble, and when people suggest guests, it sort of just gets us into new areas, and so we can keep bringing you new topics. So thank you for everybody who does that. We will see you on the next episode of The Crownsmen Show.